start recording. So I guess I have so many. Let me share my screen. So many things in my taskbar that I have to close. But okay, so I guess my plan today. What'd you say?
Sadly, I started a Valorant game, so I think I just made a call out, and you guys heard.
Oh yes.
Yeah.
Yeah. That is what that is, but that's okay. You enjoy. You enjoy your Valorant game. So, okay, I'm gonna open up ELE stuff and see what assignments we have for this section. Okay, so like I guess let's just go through it. I don't know if we really have to do chapter 15 stuff. Chapter 15 is honestly just doing the Laplace transform, which is like, we know how to do that. So maybe I'll go through it quickly.
Wait. So it's basically the same way you would do it in math?
Yeah. It's simpler because they don't even expect you to do it by definition or anything like that. They expect you to do it by table. Always by table.
All right.
Okay. So it's not like different. It's just like, what is it? There it is. Fundamentals of electric circuits. Okay, so I'll take a look at a couple questions though, see what they say. If it's anything, if it gives us trouble, then I'll try it out. But otherwise, it's just like whatever. Okay, so let's take a look at 15.6, which is already kind of a weird question. So let's take a look. Also, I have Slater, by the way, so I paid for Slater. Okay. I paid for Slater, so we can look at questions there. But still, this is trying to figure out. Okay, so find f of s given that f of t equals 5t for all 0 to t. So sorry, t is between 0 and 1s, and negative 5t for all. I have a feeling that s is not supposed to be there. Let me look at this.
It could be, right? It doesn't really matter.
But it would. But like,
it's not part of the thing. It's not part of the thing, the domain. But
yeah, it's a like I don't think they mean s being like a
variable, right?
Like, yeah, I don't think they mean it to be a parameter or anything like that. Let me just take a look here. Let me just take a look at I'll look at Slater right away. Fundamentals. I just want to see if they have it in the solution. This is what edition? Seventh edition. Let's just search this. I know they have the exact textbooks. I'm just may as well put it on my screen so you can see what I'm actually searching. It's this. Isn't it that textbook? Yeah, it's this one, but that's not the right edition. Let's see if it gets us the right thing. Practice problems. Exercise 6. Yeah, so they just fully ignore the T. They ignore the S, I mean. Yeah. That's it. They just ignore the S. Oh no, they have 2T. Never mind, they have 2T. But I think it doesn't matter. 2T. Oh no, this is just a different question. This is just a different question. Looks similar. It's just a different question. So I gotta find the. That's what this is called, right? Fundamental. Okay, so I'll look up. Results. I just Google search it. I think they have fundamentals, electric circuits. Yeah, I don't know why. That's how I am supposed to get it, but there we go. At least I get it. Question 6. I don't have question 6. Fantastic.
Wow. Okay.
Okay, so there we go. I really feel like those S's are not supposed to be there because I don't know what it wouldn't mean anything if the S's like that. So f of t equals 5t 0t 1s negative 5t 1s. 1t 2s. Like it just doesn't mean anything. Like that's just a parameter. It's essentially just f of ts at this point. That it's a function of two variables here. It's essentially just that. I really feel like that's not. Does that make sense? That it should just not be there?
Yeah.
Right. Okay, and then at this point, it's just a math question, right? It's just take the Laplace of f of t equals 5t minus 5t u of t minus 1. Or I'll just say minus 10t. T minus 1. There we go. That's it. Oh, and then I guess and then plus 5t u of t minus 2. And then it's just take the Laplace of this. But we've done that many, many times. So I think it's good I keep moving from both of you. Is that okay? Or should you, if either of you want me to do it, I'll do it.
Finish it. Just finish it. Yeah. I want to see at least one.
See one? Okay. So Laplace of both sides here. So we go by the method. So this is going to be f of s here. And then Laplace of 5t is 5 over s minus, and this is going to be minus 10. And now t, u of t minus 1. Well, to deal with this, I got to go to my calculus, and I got to look at my notes, and I got to find the theorems for u of t minus 1. Now, actually, we could probably just do this by table, but not just probably. We can definitely just do this by table method. But let's just take a look here. There's the theorem for unit step functions. So negative 10. I'll just write it as Laplace of t u of t minus 1, and then plus 5 Laplace of t u of t minus 2. So 5 over s minus 10. Now t u of t minus 1. Well, let's see how we deal with that. If I have g of t u of t minus a, this is going to be, okay, so that's an s, by the way, negative 10 e to the negative s, right? And then you want the Laplace, right, of t plus 1. Right? Because t plus a. It's t minus a here, 1, so t plus a, g of t, so there we go, Laplace of that. All right, so similar thing here, plus 5 e to the negative 2s. Sorry, that's supposed to be negative. That was negative s, yeah. Negative. Let me just move this down. That'll be a little nicer. Let me just move this down. And then times the Laplace of well, t of, so it's t plus 2 there. And so that's 5 over s minus 10 e to the negative s, and this is 1 over s squared plus 1 over s plus 5 e to the negative 2s, and this is 1 over s squared. That was supposed to be in a squared. Plus 2 over s, close bracket. There. That's it. Oh, you can simplify a little bit, but anyways, that's the whole thing.
Yeah, that's good.
Okay, fantastic. So there we go. There's that. So I'll close that. 15.7 is next. So let's take a look at what that is. 15.7 is find the Laplace transform of all these signals. Again, essentially, we've done this in math a million times. So I think it's okay. Like, that's not bad. That's not bad. That's not bad. That's also not bad. So,
yeah.
Makes sense? We can skip this one?
Yeah.
Okay. But if you want me to do it, like, don't worry. Like, I'm happy to do anyone. Just like I'm just thinking for, like, you know, just for.
They're literally just like the math midterm that we just did.
Exactly.
Right?
Exactly.
Okay. Oh, but I have a question. It's like,
yeah,
a general question. You know how like the restrictions they have for t, like from 0 to 1, 1 to 2. How come it's like, you know, in math we noticed that it's like 0 is less than or equal to t, which is less than 1. Like there's the equal, but in this case, it's never equal.
Yeah, I noticed that too, that they never say it's equal here. That's like yeah, let me think about what that could mean. I mean, that could, I guess, mean that it's not defined at 0, because probably there's some sort of discontinuity at 0. Like maybe it's like an, I don't know, it's like, well, no, it's not discontinuous though. F of t isn't discontinuous at 0. You could just put in there. I think it doesn't change the problem solving at all, right? Like the problem solving is the same. But it is like a technical difference. But I think a lot of the time in ELE, we kind of ignore the technical stuff like that, right? Which I don't think is good, but I think it's just functional for what we're supposed to do. So I think we just sort of supposed to just ignore that. Maybe the professor could have a good answer for that. Maybe they're just forgetting to write it. Honestly. Let's try this one. Determine the Laplace transform of the following function. So gotta remember how to do this. So I think first of all we gotta write the function out, obviously. It's periodic, so it's periodic. It's like three periodic. Is a period of 3. And so in that period, it's going to be, well, from here it's 5t, right? So it's 5t from 0 to 1, and then afterwards it's 0 from 0 to 3. Sorry, 1 to 3. Right, and then that's the entire, that's the function, but it is 3 periodic, so you could add 3 to any of this, and it's true. And then the oh yeah, and then there's something we do with a Laplace periodic function, I forget. But anyways, I can just write this as f of t equals well, this isn't exactly right, because I can't just take the Laplace of this, because that's not the whole thing. F of t equals 5t minus 5t u of t minus 1, so it turns into the that's what we want anyways. Yeah, let's take a look at the answer to this one, because there is, I can't just take the Laplace of this. That's not right. So okay, so 5t, yeah. So this is a periodic function with t equal to 3, period equal to 3. We can obtain the Laplace transform of the first period of the function before we apply equation 15.40. Now let's see if I can find equation 15.40 in the textbook. Here, properties of Laplace transform 15.40. There it is. Okay, so let's see. This is how to deal with period. Okay, time periodicity. Here, this is going to be interesting. If a function f of t is periodic as shown, it can be represented as the sum of time-shifted functions. So we can just represent it as that. So f of t equals f1 plus f2 plus f3. Okay. So f1 plus f1 t minus the period. Okay, plus f1 t minus 2 times period u of t. I don't know if that makes sense to me, but let's see the next thing. Same as the function of t, gated over 0 to the period. That is, we now transform each and apply. Okay, but that's that. Okay, anyways, well, this is the formula we're supposed to use. There's some sort of derivation there, but that doesn't particularly matter. Obviously interesting, but that's okay. So then you can just say f1 of s. So f1 is just the first period, the Laplace of the first period, divided by divided by 1 minus e to the negative period s. So that's what it's essentially saying. We can just take the Laplace of the whole periodic function. Laplace of the whole periodic function is divided by that. Divided by 1 minus e to the negative 3s in our case. So now I can just take the Laplace of this now. So Laplace, so I'll say this is f of s. This is 5 over s squared minus 5 Laplace of t u of t minus 1. So 5 over s squared minus 5. And then this is, if I remember, it was e to the negative s times the Laplace of t plus 1. Yeah, I think I'm remembering right. 5 over s squared minus 5 e to the negative s times 1 over s squared plus 1 over s. Okay, and then I get this. Yep, everything's right. And then just I'm just gonna take. Well, anyways, this is gonna be I can make this s squared over s here. I'll do it another one. 5 over s squared minus 5 e to the negative s over s squared minus 5 e to the negative s s, so that's supposed to be, that's a 5, and that's an s, over s squared. I just multiply top and bottom by s there. And then this is 5 minus 10. Oh no, never mind, I can't do that. 5 minus e to the negative s minus 5e to the negative s over s squared. Okay. So that is our, I'll call it f1 of s. So it's the Laplace of the first period. And now this formula tells me that the Laplace of the whole thing is equal to that, f1 of s, over 1 minus e to the negative 3s. And there we go. Just plug that in there. Does that make sense how I solved that question? I gotta add that to my notes. That's not in my notes.
Oh, wouldn't one period be 4? No, 0 to 3. Never mind.
0 to 3, yeah.
Oh,
yeah.
Yeah.
Go ahead.
Oh, okay. Question is, you know how like those, this is a sinusoidal is what it's called, right? The formula?
Like, well, this is not sinusoidal, this one here. This is just periodic.
Periodic. And this formula is for periodic, correct?
It's for periodic, yeah. So you just take the Laplace of the first period. That's what that means. Take the Laplace of the
Okay. But like, say, you know how you got your unit step function for this question?
first.
Like, in the case, this one is like triangle shape, and then like in the textbook we saw, they were like arches, right? Like, is there a difference in getting the unit step function?
No, there's no difference in getting the unit step. Oh, sorry, in there's no difference in like the method, but you have to be able to write. You have to be able to write that as a function. How do you write that as a function? I don't know. You write it as, say this is 0, this is 2, just for simplicity. And then, so it would be x minus 1 squared plus y equals 1. So rearrange, but you just want the top half, so that's actually fine, actually. Or it doesn't even matter. Wait, how did that happen? That doesn't make sense. Oh no, it does make sense. Oh, sorry, y squared. That's supposed to be y squared. That's my issue. There we go. So y squared equals 1 minus x minus 1 squared, and then you want to take the square root, but you just want the positive square root of that. Just the positive square root, because you don't want the bottom of the circle. You just want the top. And so there's your function f of t. It's really f1 of t if you want to just limit it from 0 to 2. The 1 meaning the first period of it. Right? And then, but your whole actual f is this repeated periodically. And so then you could, then you just take the Laplace of this and then divide it by 1 over 1 minus e to the negative 2s in this case. Does that make sense how I did that?
Yeah.
Okay.
Yeah. Crystal clear.
Good. And then probably Fourier would help here too. Like making a Fourier series would probably help in a case like this too. Pretty much really calling to do a Fourier series, but we haven't gotten that part of the course. But I'm sure you could solve this with a Fourier series as well. I mean, I guess you couldn't take the Laplace of it. No, never mind. Yes, you could. You could take the Fourier series of it and then apply the Laplace transform to the Fourier series. But anyways, that probably get the same thing as this. Actually, no, you definitely get the same thing as this because there's only one Laplace transform. Okay.
Makes sense. Okay.
Okay. Good to go?
Yep.
So 15.15 is done. 15.16. 15.16 is obtain the Laplace transform of this guy. Okay. Give it a try. I want to practice this a little bit, like making these weird graphs out of unit step functions. And then 17, 18, 19. Are they all this? Are they all the same thing? Design a problem to help understand the Laplace transform and see if non-periodic. That's okay. We can skip that. 17. Obtain Laplace transform of the following functions. So that's all like find the Laplace transform of this. Yeah, these probably are. Doing is 19 assigned to us. 19 is, yeah. So let's take a look. 19. Calculate the Laplace transform of the infinite train of unit impulse. Ooh, that looks interesting. So we'll definitely try this, but let's just do one thing at a time. So let's do this now. This is number 16. We won't do all the questions, but this is 15.16. So, well, I mean, actually, this is pretty straightforward, honestly. Like, I'll just write it as a piecewise function, and then So, I mean, I'll write out the unit step function, but then after that, it's pretty straightforward. So 5 from 0 to 1, t, I always forget how to write this. T is between 0 and 1, right? Then it's 2 when t is between 0 and 1 and 3. Then it's 5 again when t is between 3 and 4, and then it's 0 when t is greater than 4. Okay. So I'll just write this as a unit step function. It's going to be, so f of t is equal to 5 minus 3 unit step function, t minus 1, plus 3 unit step function, t minus 3, minus 5 unit step function, t minus 4. So it's going to be 5, and then when it hits 1, it's going to be to 2, because you're subtracting 3, and then when it hits 3, you're going to go to 5 again, because it's 5 minus 3 plus 3, and then when it hits 4, it's going to be, you're just going to subtract the 5 away. So there we go. That is it. And then you just take the Laplace transform of that, just using the formulas. So good to move on with this one?
Yeah.
It's okay? Okay. Sounds good. So I'll just cross that out in green just because we didn't fully solve it. Okay, so 17 we can skip, it's fine. It's just essentially like that's the same thing. Maybe let's try this one. Is this anything interesting? It's not really that interesting, honestly. Let's just do the same thing, I guess. Let's just do the unit step function of it. And then I definitely want to do this one. I like that. I like this one. This is good. And then we'll look from here after. Well, I like this one too. So let's do this one. Okay, so again, as just a piecewise function, f of t, this is going to be, well, from 0 to 1, from 1 to 4, and from 3 to 4. Well, we don't actually know, but and then from t is greater than 4, there's a bunch of states. So at the end it's 0. At the beginning,
you wrote a 4 at 1 to 4.
Oh yeah, it's supposed to be 1 to 3. Yeah, it's supposed to be 1 to 3. Yeah. Thank you. So 2t, 2, negative 2t, and 0. So as a unit step function, this would be 2t, and then minus, how can I do this as not being difficult? Okay, I'll just do it like this. I mean, so then minus, you're going to subtract the 2t when you have t minus 1. So now we're losing the 2t, and then I just want to add 2. U of t minus 1. Okay, and then I want to, I mean, I think I have to just subtract the 2. U of t minus 1, and then subtract 2t. T minus 1, and then add 2t. T minus 1. And so this just takes a whole bunch of, oh, sorry, I made them all ones, didn't I? I did not mean to do that. So at 1, and then we add 2, and then at 3, that's supposed to be a 3, and then that's supposed to be a 3, and then that's supposed to be a 4. There we go, that's what it's supposed to be. Comfortable with this one?
Yeah.
Yeah?
I don't know, I'm just a little confused here on why do you have so many terms?
Yeah, because I got a little bit lucky in this last one, because like I can make 5. I can make 2 from 5 without having to just remove 5 and add 2. I can just remove 3 to go from 5 to 2. But to go from 2t to 2, I just have to fully remove 2t, add in 2. And then to go from 2 to negative 2t, I have to remove 2 and add in negative 2t. And then to go from 2t to 0, well, I just have to remove the 2t.
Makes sense.
Okay, so good to move on from this one?
Yeah. Yep.
Okay, so everything's falling around me. Okay. Then I'll just scratch this one off because we did it. It's fine. 15.17. Now 15.8 15.18, well 15.7 we actually didn't do, but whatever, it doesn't matter. 15.18 we basically did. 15.19 is this next one, and this is going to be a little bit interesting. So it is 2 periodic. So we're going to have to deal with the periodic stuff. Infinite train of unit impulses. So this is essentially f of t equals, well, how would I write this actually? Okay, I think I would write this as, it would be delta, little delta of t if t equals 0, and 0 if t is not equal to 0. Or
Maybe
maybe
like
I'll,
2n or something? When t is equal to 2n?
yeah, you're right. You're right. That is actually what it is, but I don't know how to take the Laplace of that. That's the thing, right? So I wouldn't be able to write it like that. So I think we just have to use the same formula as like here, like this one. Take the Laplace of the first bit. So I'll just paste it here. But yeah, well, we'll see. Anyway, so 0. I think I'll actually say this a little bit differently. T is between 0 and 2. So but that doesn't mean anything. What? This f of t1 is just sigma of t. That's it. There's nothing else I have to do. There's no unit step functions. It's just that. And then if I take the Laplace of that, right, it's just 1, I think, right? It's just 1. Yeah, Laplace of this is just 1. So f1 of s equals 1. So this is just going to be 1 over 1 minus e to the negative s, because, oh, sorry, negative 2s. So Laplace of this, so f of s of the whole thing, because f1 of s is just 1, so that goes there, and it's just 1 minus e to the negative 2. I'm going to check this one, but does that make sense?
Yeah.
I will check it, though. Let's just take a look. So, number 19. Yeah, that's right. That's right. Okay. Great. So, that is 19 crossed off. So, 21. Obtain the Laplace transform of the periodic waveform. This guy. I think we're good to skip this one. Is that okay? That's good?
Yeah.
So I'll cross that off. 23 and 25. 23. Determine the Laplace transforms of the periodic functions. Maybe let's try this one. That's t squared. Maybe let's try this one just because it's a little bit of funny business. 23 and then 25. Let f of s equal that. Use the initial values of that and to find that and that. Verify your answer, part A, using partial fractions. Okay, I'll just do part A, and then part B is something else. It's not actually that hard. Let's do this one though. I do like this one. This one's not bad. Okay, and then again, let's just do part A. And then 27. I just may as well look at what's 27. Determine the inverse of all these things. I think we're good with that. Can I skip that? Determine the inverse of all these.
Yeah.
Yeah, because we did that a lot in math.
Yeah.
29. Find the inverse of that. Just do partial fractions essentially. That'll be it. Maybe there'll be some funny business, but nothing really. So let me just already cancel these off. So 27, 29, we can cancel off. 35, 37. Oops, that's the wrong textbook. 35. Obtain f of t for the following transforms. Again, this is just inverse.
Partial
I mean,
fractions, yeah.
it's just partial fractions, and then one of your partial fractions will have an e on it.
The unit step function.
So, and then actually this will be a little bit of convolution because it's going to be, you're going to separate this into 4 over, maybe let's do one of them. So instead of me explaining,
all right.
let's just do one. In fact, let's particularly do this one. Anyway, so that's 35. So cross that off. 37 and 37 twice. Apparently we're supposed to do 37 twice. Inverse Laplace of all these guys. Again, it's really not going to be anything different than what we've done in math. It's going to be the same thing. So this one will take convolution. The one I screenshotted will make you do convolution. So let's just do that. Okay. So let's go in order here. So we'll do this. Determine the Laplace transform of the periodic function. Okay, so we just want to write it as a periodic function. So f of t equals, okay, so it's essentially well, it's 2 periodic, right? Like 2 as in like the number 2 periodic. So from 0 to 1, and then from 1 to 2 it's different, so it's just 1 and then 0. And so then f of t is just 1 minus,
Or would it not be -1?
you're right, it would be -1,
All right.
exactly, yeah. Minus 2u of t minus 1, and then just take the Laplace of this. So Laplace of 1 is 1 over s, and then this is minus 2 over s minus 1, I think, or no, that's not right. I don't want to do that. It's gonna be Laplace.
Wouldn't it just be e? It would be e. There wouldn't
Oh
be an
yeah,
s.
you're right. It would be, well, it'd be e to the negative s. Yeah, e to the negative
Yeah.
s. Yeah, that makes sense.
That's it.
Times the Laplace of.
I'm so sorry, guys. It just what happened was I started the game the second you said that you were like about to start.
Yeah.
I was like midway through it, so it's like I had to listen to your lecture while I was like popping off. So I'm sorry.
Were you popping
But
off
yeah,
though?
I was. It was the first
Okay.
time I was playing with Rays, so I was doing all right.
Okay,
But
good,
anyways,
good.
that's besides the point. I'm here now, so let's get to it.
Okay.
All right.
Did you hear like everything we were talking about?
Yes, I am gonna have like quite a few questions.
Okay.
But I'll ask as we go.
Okay, sounds
Yeah.
good. But let me just finish taking the Laplace of this. I don't know, is that right? Hold on, something's confusing me for some reason. I like this textbook for Laplace stuff. Where are we? Appendices. There we go. So Laplace of the unit step function is e to the negative as over s. Yeah, e to the negative as
Oh, there
over.
should be an s. Okay.
Yeah, e to the, I knew there was some sort of over s there. Yeah. So a -2 e to the negative. Yeah, there we go. The reason is because you're using the fact that this is really u of t. This is really 1 times that, right? If I just factor out a common, like the -2, not common, but I mean if I just like take away the -2, it's really the function g of t is 1, and then u of t minus 1. So that's going to be e to the -1s, and then Laplace of 1, which is 1 over s. Using this formula, it's going to be, you need to have the Laplace of 1. G of t plus a is just 1. So then that would be 1 over s. So okay, we figured. Okay, let's try. I really only got 2 more questions for chapter 15. So let's just finish these 2 questions, and then Hashim, if you want to ask your questions after.
All right.
Okay, so I gotta find my notes for this one because I don't remember how to do it. I mean, I know how to do it. I just forget the exact formula. So essentially, we're just using the fact that, well, this following fact that I'm about to show you. Gotta find it. But it is here somewhere. My entire note for chapter 15 is a single page because I don't know what else to say. It's just essentially the Laplace transform. Anyways, I'm using this fact here. The initial value f of 0 is equal to the limit as s goes to infinity of s f of s. The final value f of infinity is the limit as s goes to 0 of s f of s. Yeah, that's it essentially. So I think how I'm going to deal with this, I got to take some limits here, which is a little bit of annoying. But anyways, s f of s is equal to 5s squared plus 5s. And this is s squared plus 5s plus 6. Wow, 5s and s's I know are very rough with my handwriting, so you're going to have to...
Where does the s in front of the fs come from?
I have no idea. I have no idea why there's an s
Okay.
in front of the fs. I just know this formula.
Okay.
I wish I had a better answer for you. Anyway, so now we just take the limit as s goes to infinity, right? So that's going to be 5, right? Because these terms go away. So it's just 5. It's just 5. You just take the coefficients. So there we go. So that means f of 0 equals 5. And then the limit as s goes to 0, well, we can just plug that in. It's just 0. Right? So f of infinity equals 0. There we go. That's the whole thing. I'll check the answer for that one, but that's it. Problems. Oh, they don't have the answer. Okay, well. And then verify your answer by finding f of t and then using partial fractions. Like by using partial fractions. I mean, that's essentially just find the inverse and then take the limit. I think we're okay with that one. That's
sorry
yeah.
for this. I remember during the lecture, he was going over this, these initial and final values. It didn't click in my head why f of 0. That's it. You do s approaches infinity. I would assume that as f approaches like f bracket infinity, s equals infinity. So do you understand that correlation? Because like sure, like I'll listen, I'll look at this formula and be like, okay, whatever, I'll just take it for how it is. But like if you could provide like some sort of insight if you have on why it's like that.
I don't really have insight, but let's take a look if in the textbook there's anything that I can understand quickly, and then there possibly is time differentiation. Let's skip that. That's not it. We don't really care about that. Frequency, we don't really care about that. So this.
It's just weird how t equals 0. That's what it means when s is equal to infinity. It's
so let's try to figure it out together. Let's read the part. Yeah. So the initial value and final value properties allow us to find the initial value f 0 and final values f infinity of ft directly from its Laplace transform. To obtain these properties, we begin with the differentiation property, namely, so that Laplace of the derivative of a function is s f of s minus f of t. Is you comfortable with that?
Yeah.
Right, that's the property it has. So if we let s go to infinity, the integrand, the thing in the integral, this thing right here. So we take essentially these two together. Let s go to infinity, the integrand vanishes due to the dampening exponential factor. So this turns into 0. Right? This turns, because it's going to be e to the negative infinity, so it's 0, integral of 0 is 0. So you just get that equals 0, limit as s goes to infinity of that equals 0. And then you can just take the like limits separate under addition and subtraction, right? Like it distributes. That's the word I'm trying to say. Distributes. So you just distribute the limit onto this, and then this is a constant. The limit as s goes to infinity of a constant is just the constant. And you just move that over and you get that.
Okay.
Does that make sense?
Yeah.
Okay, and then let's take a look how we get the other one. So let's do it here. This is known as initial value theorem. For example, we know from whatever, this is a particular example. I don't really care. In equation 15.41, so if we go back up to here and we let s go to 0, right? Let s go to 0, then this is going to be e to the negative 0. So it's just going to be the integral of the derivative of f, right? You see it's going to be so this is going to be 1. So the integral of the derivative of f. So that's just going to be f. I think. Oh, here. Sorry, they do it here. So let s go to 0. So this is just going to be df. Oh, yeah. This is just going to be the integral df. Because, okay, well, a little bit hand wavy, but this is going to be 1, right? This is going to be 1 there. So dt and dt cancel. So it's going to be the integral of df, of 1 df, okay? Which is, and definite from 0 to infinity. So you're going to get that, right? F of infinity minus f of 0 minus, right? Is equal to that. Okay, limit as s goes to 0. Distribute again. So a couple steps in between missing here. Anyway, so distribute again. You're just gonna, these two are gonna cancel off either side. Right? These two are gonna cancel. They're both constants. And then you just get the limit as s goes to 0 of s f of s equals f of infinity. So the s times comes from the property of Laplace transforms, that s f of s is equal to the derivative of the function. The Laplace of the derivative. Does that make sense?
It's definitely more insight. But I think it's just gonna have to kind of like sit in my head for a bit until it really clicks. But yeah, no.
Essentially, go ahead.
No, it's just like these pages that you showed me, like these derivations, they do make sense.
Okay,
good. Like I'm getting there.
Good. Yeah, I don't know. There's probably some deeper meaning that we're missing here, right? But they sadly don't teach us that much. So, anyways, there's that. Okay, so that's that question, and then let's take a look at this last one. I just want to find the Laplace inverse of this one. It's just kind of an interesting one because you do convolution in it. So let me just show you how to do it. So 4 over, this is going to be s. Well, let me just factor this. Two numbers that add to 5 multiplied to 4, 1 and 4. So s plus 1, and then s plus 4 minus, or I'll just say plus, negative e to the negative 2s over s plus 1 over s plus 4. So this one you just partial fractions it and then deal with it there. This one, slightly different. So let me actually write them both as, this is 4 times 1 over, and then this is negative that times 1 over that. So partial fractions both of these guys. Right? Let me do it quickly. So I'll just the calculator. So 1 over s plus 1 plus 4. So that's just going to be 4 times, and it's going to be 1 over 3 over s plus 1 minus 1 over 3 over s plus 4 plus e to the negative 2s times 1 over 3 over s plus 1 minus 1 over 3 over s plus 4. Okay, and so now Laplace of this is nothing crazy, right? So it's just going to be 4, or Laplace inverse of this, I should say. Laplace inverse of well, essentially of 1/3 for s plus 1. Okay, and then you have minus 4 Laplace inverse of 1/3 over s plus 4. Okay, and then Laplace that's supposed to be minus there, right? And then Laplace inverse. I can't take the e to the negative 2s out, right? Because that's not a constant. So it's just e to the negative 2s. So we just do this essentially. One. You take the third. You take the third out. And it's just gonna be 1 over s plus 1 minus 1 over s plus 4.
Sorry, so what you do is like you're doing the Laplace of e raised to the power of minus 2s. Multiply that by the Laplace of your partial of like each of those terms that you have in the bracket.
Well, are you saying that's what my next step should be?
No, what I'm saying is, well, is like, is that what it is? It's like you do so like exactly like you did how you broke it into those two terms on the left side where you have the 4.
Mm-hmm.
You would do the same thing for those two terms that you just did partial of on the right side inside the bracket, but you would just. And then you would also do the Laplace of e raised to the power of minus 2s, but just multiply it by whatever Laplace you get from inside.
So remember, in Laplace domain, right? In Laplace domain, when we're talking about Laplace stuff, if f of s times g of s, if we have that, if I want to transfer back to time domain, that's going to be f of t convoluted with g of t, not times. Right?
Oh, okay. Yeah.
So here we have that multiplication happening. So I'm going to have to do convolution when I go back to time domain.
Okay.
Right? So that's the logic of that. Here I could separate it. That's fine. I could separate it here, right? Because it's not like I'm not multiplying functions together really. I'm multiplying constants. So the constants can just come out. So this is just going to be 4 over 3, and this is going to be e to the negative s t. No, e to the negative s.
Yeah, I'm trying to remember exactly what I did during the test, so I'm kind of scared if I did it the way that I thought what was right.
Let me just check the textbook here. How do I do the Laplace of 1 over s minus a? Yeah. So that's right. So 1 over s plus a would be e to the negative at. So
yeah,
that's right. Minus 4 over 3 e to the negative 4 at sorry, that's supposed to be a t. I'm in time domain. Minus 1. Why is there no 4 there? Oh yeah, there shouldn't be 4. Okay, and then here again we have multiplication happening. So in time domain it's going to be convolution. So I just have to determine this e to the negative 2s is the Laplace of what? So it is the I can write that as the Laplace of 1 over s plus 2, right? Times the Laplace of what is this? So it's going to be e to the negative s minus e to the negative 4s. So I can just rewrite both of these things as the Laplace of something. As the Laplace of something. And so now this is just going to be, well, 4 over 3 e to the negative t minus 4 over 3 e to the negative 4t minus a third, okay? And then this is now finally going to be... No, that's wrong. What am I talking about? Hold on. What did I just do? That's not right. Laplace of 1 over... No. This is not right what I just wrote here. It's right that I'm supposed to do two Laplaces, but that is not what the Laplace of that is. Laplace of what gives me e to the negative 2s? Laplace of...
Yeah, I think you had it right. 1 over s plus 2.
But...
Or,
1 over...
sorry, yeah.
That doesn't make sense. How can I be taking the Laplace of something already in Laplace domain? S. The S doesn't make sense for the S to be there.
That is weird. I don't know.
Yeah. So we're getting something wrong here. Laplace of what gives me e to the something. Do I have any e to the somethings here? E to the somethings. E to the somethings. It's not good to see that it's at the end. Oh, okay, so it's just this function.
Yeah, that's what it was. Okay, then I think I did do that on the midterm.
Well, I don't think we didn't have this. On the math midterm we didn't have this function.
Yeah.
We didn't have this function here.
Oh yeah, you're
Dirac
right.
delta
Sorry, I
function.
thought that was a unit step. Okay.
No.
Well,
I also thought it would be
yeah.
a step. Yeah. That's not how I dealt with this question. Sorry, there's something. I'm doing something wrong. Wait a second. E to the negative. I did this question. We had one like this on the midterm. Yeah, we did.
Yeah, it was. I remember having something like this on the midterm.
Let me look at what I did. No. Let's go here. No, that's MTH 141. Let me take a look here what I did. There we go. So this is going to be here. No, it's not that question. It's not that question. This one, and then I had to do Laplace of. It's not this one. Question. This question. Was this one? Yeah, it was this one. Yeah. Oh, okay. So I don't write. Yeah. Okay. So there was no convolution. Never mind. What am I talking about? There would be convolution if there was something more complicated happening.
Yeah. Okay. Good.
So okay. Yeah. Okay. So if I go back to ELE here, look at what's happening with this question. Yeah, I'm overcomplicating it by saying that. No, this is just e to the negative 2s. This is Laplace of e to the No. I gotta focus here a little bit. 1 over s plus 1 is just e to the negative s. No, e to the negative t. That's what I'm getting wrong. E to the negative 4t. Now, I just use another theorem that I've got here, which is just that... go back to math. Just use another theorem that I have, which is the first translation theorem, which tells me that e to the... That's Laplace inverse. No, I need the second translation. Never mind, it's not the first one. Second translation. So Laplace inverse of e to the negative as f of s is f of t minus a. Okay, so it's going to be negative a third e to the negative t minus 2 minus e to the negative 4 minus 2 times the unit step function t minus 2. There we go. That is your Laplace inverse. I don't know why I made that so complicated. Hopefully that makes sense. Hopefully that's good. How I finished that. Do you have any questions?
Yeah, so the e raised to the power of minus 2s, where is that in that formula? That's right, the
E to the
second line,
negative,
I think.
yeah, I'm taking the Laplace inverse of e to the negative 2s f of s. That's my f of s.
Also, exactly. So now your functions are in terms of t minus 2.
T minus 2,
Or-
exactly.
yeah,
F of
exactly.
t minus 2, u of
Yeah.
t minus 2.
Cool, cool. Yeah.
Okay. Okay, so there's that one. That was more it wasn't actually that complicated. I thought there would be convolution in it. That's why I thought I was making it more complicated. There's no convolution. Okay, anyway, so that's actually everything for chapter 15 that I wanted to go through. So let's go to chapter 16 now. Let's see what they assign.
Before we go,
Yes.
can we go to question 21? I still don't quite understand this one. Yeah. Oh, 19.
19? 19? Okay, yeah.
Yeah. Like, did you uh did you just take the like Laplace inverse of 1? That's why you got s of t?
Here I took the Laplace of both sides to get from here to here. Laplace of f of t is f
I
of
don't
f.
I don't think that's s of t. I think that's delta t, no?
Delta t.
Yeah. This here, this
Yeah.
is delta, like the
Yeah.
Dirac delta function. That's like this thing, Dirac delta function. Do you remember that from ELE from lecture? If not,
No.
I can. Okay, yeah. So the Dirac delta function is equal to infinity. Say is equal to infinity if t equals a, is equal to 0 if t is not equal to a. So that's what this is. It's called the impulse function. It's just a single at a infinitely small section of the x-axis. It's at infinity, and then everywhere else it's just 0. So it's like an impulse exactly at that point. And so the main property that's actually useful about this is that the Laplace of it's called the delta function or the Dirac delta function, whatever.
Oh, yeah, so these lines are the impulses.
They are the impulses going up, exactly.
Oh, okay.
So the period is 2, and all it is that at the start it's just an impulse, and then so essentially at the first period is just the impulse, and then it's 0 anyways.
Oh, okay.
And then I just take the Laplace of that both sides, and so then I get so then I just use the formula that we talked about earlier, which is that the Laplace of a periodic function is just the Laplace of the first period divided by 1 minus e to the negative period s.
What happens in the yeah, you wanna go first?
No, go ahead.
All right. Yeah, like in this case, I just noticed that I thought those like arrows meant like it stops at 1, but you say it goes to infinity, right?
Yeah, it goes to infinity. Yeah. This is like an impulse. It goes.
Oh. But what if it's in the case where it's like it's a constant number instead of like infinity?
Then you just have a different function. Then it's just not the Dirac delta.
Okay.
Then it's just something. I don't know.
So it's about your piecewise function that's not making sense to me, because it's like, where in your piecewise function are you representing that it happens at every 2 increment?
I'm not.
You're not?
No.
So you're just supposed to...
So this is technically f1, the first period of.
So your first period is between 0 to 2.
Mm-hmm. I'm only representing the first period.
And why is that? Is that...
I have no other way. I can't write... I could take the Fourier series of this to get the periodic one. If I take the Fourier series of it, I would get the periodic.
But we don't need to do that in ELE.
No, well, we have a section called Fourier series, so when we're there, possibly. But for this question, we don't.
Okay.
We do have a unit called Fourier series. And also, Fourier series is just there's a lot of that in ELE.
Okay, so now that we have that piecewise function, how'd you go on to find f of s?
Well, I just wrote this out because this is like a little bit too much. Like, I can just write it as this. That's the same function. There's no difference there. Because remember, the Dirac delta function is just, it's infinity and then 0 everywhere else. So there's not even a point for me to write this, really. It's just that. And anyways, this is infinity at 0 and 0 everywhere else. So does it make sense that this is equal to this? And if it doesn't make sense, where would they be different? Essentially, try to tell me where's the point where they would be different. I'm saying this and this, I guess.
Because like there's no restriction on t to state that it has to happen every 2 increment. Like for
You're
example,
right.
say you want to sub in t at like 0.5. There's
That's,
nothing telling you that that can't happen.
yeah, but this would return 0, and this would also return 0. You can't, right? Because delta of 0.5 is equal to 0.
I
Delta
thought it
of
would e-
delta
yeah.
of 0 is infinity, right? If the input is 0, it's infinity. Any other input, it's 0. It returns 0. I'm saying here.
Really? So that delta function in itself just tells you that the second you sub in 0, you get infinity, and you sub in 2, you get infinity. Anything else?
Well, not even 2. No. I'm only looking at this first period here, with that not including 2.
Oh.
Okay? But look, I'm saying that by the fact that I'm saying f1 as in the first period of this periodic function. But the reason I only need that is because look at the formula. The Laplace of a periodic function is equal to the Laplace of its first period divided by 1 minus e to the negative, this would be 2s in this case, because period's 2.
Okay, so when you went on to solve the rest of the question, you put delta t in the numerator, right?
Oh, well,
Because,
the Laplace of it, which is 1.
okay, yeah,
I put the Laplace of it.
I see.
And then it's just 1 over 1 minus. I don't know where this formula comes from. We can probably take a look at that too. But anyways.
Also the question before this one.
Okay.
Yeah, could you go over this? So, like how you created your piecewise function?
Mm-hmm. So it starts out as 2t. That's
Yeah,
the function
that
2t.
makes sense.
Then at
You're gonna-
1, this is saying, oh, whoops.
Oh, wait, sorry, this is the wrong question. All this is asking for is just to represent the unit step function for this, right?
And then take the Laplace, but I just didn't take the Laplace because it would just be a bunch of formulas. It would just be
Oh,
doing
okay.
the formula function.
No,
Which is a
yeah,
bit
sorry, I do understand this.
Okay.
We're good.
And this one, and Kevin, how are you feeling?
Oh no, yeah, that's good. That's
You're
good. I
good
understand.
about all these ones? Okay.
Wait, sorry, go back down. That one where you're, no, the one below this one? Lower?
This
Yeah,
one?
that one, yeah. So over here, we're at 5 all the way till 0. Shouldn't there be some sort of impulse in this case? Because it's like a
Oh,
vertical line?
Because that, yeah, I am ignoring that. I don't know how to deal with it. This is the answer.
So like we're not, so because we didn't, just because we didn't have the impulse equation in this, that doesn't mean we solved it wrong.
Yeah, this isn't an impulse though. This is not an impulse because this is
It's
not
not.
infinity. It goes to 5. Right? The direct delta function goes to infinity.
Yeah. The
So,
way I'm thinking of it is like the slope is infinity.
You're right. The slope is infinity, but like this isn't actually part of the graph. This vertical line here. That's just there for our representation, right? Like a square wave. When we see a square wave, like in whatever circuit squares we're gonna see square waves in, right? We usually see it drawn like this, right? Because
Yeah.
that's what it is from a oscilloscope. It'll look like this, right? Because
Yeah.
you can never actually have a vertical, like this is really, if you zoom in, it's really like that, right?
Yeah.
Well, you zoom in you stretch it out, I guess I should say. It's really like that you're seeing because you can never have a vertical slope. But the idealized one is this. There is just no vertical part, right? If there was a vertical part, it wouldn't be a function. Does that make sense? Like, you'd fail the vertical line test. So the actual thing, and it's usually like including there, not including there, including there, not including there.
So an impulse would specifically look like that case that we had, where it's like an arrow pointing upwards.
Yeah, specifically, it's an arrow upwards to infinity. Yeah, exactly.
Oh, okay. Okay.
If this was just a line up, no arrow, I would have no idea how to do it. That's not a function, so it doesn't matter.
Yeah.
I guess it would be like it'd be equivalent to just saying this if there were just these points, and then I guess you could actually deal with it. But then I guess you're also not defining. This is just undefined. So I guess I could deal with this. Essentially, this is what I could deal with, and then a bunch of holes here. Right, like that I could deal with.
This the midterm, or sorry, the exam for ELE is confirmed, or not confirmed, but very probably going to be multiple choice.
Yeah, I heard the professor talking about it.
Yeah, I don't know how many multiple choice, but like
Not I don't like that. I'm not excited.
yeah, they got to even out the average somehow. So
Yeah, there you go. Okay, so good with all these questions. Any other
Yeah,
questions
yeah.
about
I'm
any
good,
of
I'm good.
this? Good. And Kevin, you're good too with everything we
Yeah,
talked about?
we're good.
Good? Okay.
Yeah.
Great. So then I think we're done. There we go. We're done with chapter 15. Let's move on to chapter 16. So
16.
16.7. Let's move on to 16. Close that. Okay, 16.7 we're starting with. Okay. This is just solve this differential equation using the Laplace. Is that okay? I just skip this one?
Yeah.
That's a pretty basic one. It's good with you, Kevin, too?
Uh,
This is just
I
you would
kind of want to cover it just in case.
okay, sure. You'll see we did this in math.
Oh, okay, okay.
So you're just gonna take the Laplace of both. We have the initial values, right? So we're just gonna take the Laplace of both sides. It's gonna be
I remember already now.
right minus right, so that it's minus s. It's gonna be a 6.
Y, I think or something. Oh,
Well, but it'll be I of 0, right? I of
yeah,
0
okay.
essentially, right? Minus 12, right? Plus 2s f of s minus minus 6 equals plus 5 over s equals 5 over s squared equals 10 over s, and then you just solve for f of s and then inverse Laplace.
Okay, okay.
Is that fine
Thank
for
you.
that one?
Thank you.
Yeah, no problem. No problem. Okay, so let's. Here, how about I instead of scrolling up and down all the time, I'll just take the screenshot. Oh no, it's. Let me just go back to that. How are you guys feeling about chapter 13, the magnetically coupled circuits and stuff like that?
You're talking about ELE?
Yeah, ELE, chapter 13.
I don't even know what you said, so I think that tells you enough.
The like mutual inductance, that stuff.
Oh yeah, yeah. No, it doesn't seem too bad. It seems kind of like
Yeah,
straightforward-ish. Yeah.
Yeah. There's probably I think there's a lot of physics we're missing out on about like how inductors and capacitors actually work.
Yeah. No, that is true.
So I'd like to learn that, but other than that, like I think it's making sense. Kind of.
Like everything else, like it's like the basic sort of stuff that we used from before. Like it's a lot of KCL and stuff.
Yeah.
But the one thing is, or sorry, KVL, I mean, not KCL.
Well,
But the one thing, because in the examples that we did, it's usually like around a loop, a KVL loop.
Mm-hmm.
But what was I gonna say? The only thing that kind of throws me off is when he adds those extra expressions, because I never understand where
What's
the
the
signs come from.
extra expressions?
So you know how like if you have like those like exactly like that, or like you have like a dot sort of like around it, like two inductors.
Yeah.
I hope I'm thinking about the same chapter that you are.
Yeah. That's the chapter.
Yeah. So like what happens is like when you're doing the KVL sort of equation, you have to add extra terms that are specific to
to the mutual voltage. That's the mutually
exactly.
induced
And
voltage or something like that. Yeah.
And it's the sign that I don't get because he kept on trying to explain it to me.
Yeah, I remember you asking.
Yeah, it just did not click. So
Yeah, I wish I could explain it, but I just can't. But I haven't written my notes for it, so I will no help at this moment. But in the future, when we do this practice, I will hopefully be able to explain it properly. Okay, so let's try this one, 16.30. This is a full actual Laplace question. This is like do the Laplace stuff. So let's give it a try. So find VO for t greater than 0. So we're going to do this by taking the Laplace of everything, converting essentially to Laplace domain. So how do we do that? I will be looking at my notes this whole time. Oh, by the way, I should upload my notes. I don't know if they're updated actually. Let me check. You guys want them? I will update them. Oops. ELE. Okay, I updated it on Wednesday, so nothing much has changed. Just upload the new version. Okay. So if you want my notes, you can go. You probably know my website. I'll just put it here. And you can get them there. It has like I put all this stuff nicely in there. This I'll show you. So like doing the Laplace stuff, it's like in Laplace domain, resistors in Laplace domain turns from that to that. Inductors in Laplace domain, so it turns from that to one of these two options. There's the equation.
And this is not found like you're not taking screenshots from the textbook.
Well,
like,
these circuits are from the textbook, like these exact thing, like this stuff. But other than that, like all the text around it and just like how I have it set up is not just from the textbook. It's just like I wrote that.
Very impressive. Good job, Adam.
Thank you. I like putting nice notes together. I'd also love to be able to make my own circuit diagrams, but it just would take way too long for me to make my own circuit diagrams. And these are good. Like as long as they're good from the textbook, that's what matters.
Mm-hmm.
Okay, so let's do this. Let's turn everything to Laplace domain. If I remember correctly, I don't think I actually even have this in the thing. I just take the Laplace of the source. I don't think I don't have to actually do anything fancy to it. It just turns into the Laplace of the source. Quite certain. So the Laplace of 2u of t is something. 2e to the negative. It's just 2 over s, I think. I think it's just 2 over s. Yeah, it's just 2 over s. So let me just redraw the circuit. 2 over s. So the resistor turns into nothing different happens. It's just 1 ohm still. It's just 1 ohm still. Okay, the inductor has something fancy going on, so give me a second there. This is 1 ohm. Capacitor has something crazy going on too. And then this is just going to be 1 over s current source that way. Okay, so now that we got that, let's deal with the inductor and then the capacitor. So the inductor turns into
just s, right? Because isn't j omega equal to s?
J omega is equal to s, yeah.
Yeah, so I'm thinking that its impedance is equal to 1 j omega. So that means it would just be 1 s.
Oh, yes. Yeah. You're right. It's just that we also have to deal with the fact that we're going to have, so it's going to be, it's s times l. So it's s times 1, so it's just s. Okay. But then I'm going to have to add a little voltage source here, which has a value Li of 0 minus. Now, we can find what I of 0 minus is from here, right? So right before the switch closes, so this is essentially, this is 0, this is not there.
Wait,
right?
So where is the switch?
That's the switch. Like the unit step function.
Oh,
unit step function
you're right. Yeah. Okay.
So it's a short circuit, and that's not there because it's an open circuit. I'm looking at t equals 0 minus, right? So this is not there. Just cut that off. That's a short circuit. And then, well, they didn't actually tell us if there's any kind of initial. I guess they don't have to tell us. Why would they have to tell us? So, no, I think we can just assume. I think we can just assume that there's no sources. So why would there be any? Why would there be any energy in the system? So it would.
Yeah,
it would just
that does make sense. Yeah,
Right.
I don't think it would have any sort of.
So I think I have 0 is 0, 0. So we can just forget about that. We don't need that. We don't need the source. But it's just good to like mention it, right? Just to say that we thought of it, right? But since I of 0 is 0, we can just write that as a short circuit. And then from here, I can just connect that. And now the capacitor is somewhat similar, actually almost the exact same. So, interesting. So the capacitor turns into 1 over SC. So it's going to be 1 over S times a half, right? Which is just 2 over S. Okay. And then again, I have this plus minus V of 0 over S. But V of 0? I think we can again just assume that that's 0. So I can just say that that's just there's nothing there. Assuming it's 0 because yeah.
You're using that same sort of source, right?
Well,
Except it's just you're checking v of 0 minus.
I'm checking. Yeah, I'm just checking what would this voltage here be at 0 minus, or at 0. It's not even 0 minus this time. I don't know why. I don't know what's the difference. But
It
no,
will still be 0, yeah, but I just want to know how the inductor and how a capacitor differ when you're trying to go into Laplace.
oh,
So you know how you added that extra source?
yeah. So
Okay, so that's how
so
it
here.
is. Yeah.
So this is so there's two options. When you're converting a inductor in time domain to Laplace domain, you can do either of these two things, depending on what's better
Okay.
for the circuit. You notice either way, if I of 0 is equal to 0, it's the same circuit. If I of 0.
Yeah, exactly.
And then for
And
a
the same
capacitor,
sort of thing.
it's the same sort of thing. It's just
Awesome. Yeah, your notes are actually very clear with that. I like that.
good. That's why I write them like that. I just want them to be just helpful while problem solving. Okay, so then we have this, and that's everything. I think that's good. Okay, so now we're in Laplace domain. We're looking for this voltage. So I can just do whatever.
Nodal.
I don't know. Nodal? Okay. I'll do nodal.
Yeah, I like nodal.
I like nodal too. So there we go. There's my nodes, and there's my ground node. So then I can just say just V1, V2, V3, but V1 is just 2 over S or whatever. So the V2 equation, let's call it V1, I guess. V1, V2.
Wait. Wouldn't? Oh wait, no. Okay. Yeah, I don't think it will work that way because I just saw that. Wait, like the V2 is just equal to 1 over S. So that means the voltage across VO is just 1 over S.
That's not a voltage source. That's a current source.
Yeah, you're right. You're right.
That's the
Okay.
V1 minus S 2 over S over 1 plus V1 over S plus V1 minus V2 over 1 equals 0. And then V2 equals not V2 equals, sorry, V2 equation is V2 minus V1 over 1 plus V2 over S over 2 over S minus 1 over S equals 0. So now I just solve how I usually do. So V1 minus S, oh my god, 2 over S plus V1 over S plus V1 minus V2 equals 0. V2 minus V1 plus, so it's going to be V2S over 2. Oh god, I keep writing S's instead of 2's. Minus 1 over S equals 0. Okay. I'll just substitute whatever. So I'll just solve for this. I'll solve this for V2, I guess. So it's just going to be solve for V2. It's just going to be this. Go. So, but let me simplify that a little bit. So it's going to be V1, and then it's going to be 1 plus 1 over S plus 1 minus 2 over S. So that's going to be V1 times 2 plus 1 over S. So 2S over S, 2S plus 1 over S minus 2 over S. There we go. That's equal to V2 still. So now I'll just substitute that into here. Oh, it's a little bit rough, but okay, that's fine. I'll substitute that into here. Let me just rearrange a little bit. So it's V2 1 plus S over 2 minus V1 minus 1 over S equals 0. So then this is going to be V1 2S plus 1 over S minus 2 over S times 1 plus S over 2 minus V1 minus 1 over S. 0. Now I got
Adam,
yeah.
Could you just explain what you did on that second line where you first had V2 equal to V1 bracket 1 over S plus 1?
This, how did I get from here to here?
Exactly, yeah.
So, well, the 1 plus 1 turns into 2.
Yeah. So now you have 2 plus 1 over s.
2 plus 1 over s, which is the same thing as 2 over s over 2s over s plus 1 over s.
Okay, yeah,
It's
I'm good.
2s
I'm good.
plus 1.
Yeah, I get it.
And then now we're just gonna FOIL, so it's just gonna be v1 2s plus 1 over s plus v1 s is canceled. v1 2s plus 1 over 2. It's that times that. And then minus 2 over s. Is that s over 2? Oh, sorry, my writing is very bad. S over 2. So it's just minus 1. Minus v1 minus 1 over s. 0. Because that times that. That's 2 over s, and that's s over 2. Multiply them, we gotta get negative 1. And then now we just solve for v1. So v1 2s plus 1 over s plus 2s plus 1 over 2 minus 1 equals 1 over s plus 1 plus 2 over s. That's it. And then, well, now we just got this horrible thing to find the Laplace inverse of. So that's 1 over s plus 1. So 3 over s. 3 over s plus 1 over 2s plus 1 over s plus 2s plus 1 over 2 minus 1. Okay, so we got to find the Laplace inverse of this. So let's give it a try. Probably made a mistake in here somewhere, I'm going to be honest, but we'll see when we get there. v1 is, so that's going to be 3 plus s over s, because s over s. And then this is just going to be, well, also this is going to be 2s over 2s. I'm got to multiply by an s here, right? So s there. You know what? Let me not do this. Here, let me write it again. It's gonna get confusing if I do that. So this is 2s over 2s. This is now over 2s. I don't know why I put those brackets there. 2s is what I meant to say there. Again, I apologize for my writing. 4s plus 2 plus 2s squared plus s minus 2s over 2s. And so then that's just going to be 3 plus s over, oh, I'll say s plus 3. S plus 3 over 2s squared plus 2s plus 7. Okay, v1. And then I'm just going to use a calculator here.
So isn't it supposed to be plus 3s? Because it's 4s plus an s minus 2s.
Oh, I missed that s. Yeah. Thank you, that's good. And so I will do a Laplace inverse calculator. It will be s plus 3 over, s plus 3 over 2s squared plus 3s plus 7. Hope it gives me something good. It gives me something crazy. Not crazy, but crazy for the first Laplace question to have that as the answer. But that could be the answer. That's fine. I mean, it's nothing we couldn't do. We could do this. It's just that it's a lot of roots. That doesn't really make sense. Anyways, let's check this later answer. This is 16.30. 16.30. They do not have the solution for 16.30. In fact, they do not have the solution for most of chapter 16 problems, sadly.
Wow.
So, not the best, but okay. Let's check. I'm going to see if they have the solutions for chapter 13. Yeah, they do have a lot of solutions. So that's good. Okay, so well, I don't know how to check my answer. That's probably not right. I'm going to be honest.
Okay, but either way, like, oh,
Well,
actually, I was about to say that we would get part marks on the exam, but not anymore.
Yeah, not anymore, right? Anyways, that's also v1, not v2, but I could just solve for v2 by just multiplying that by 2. Oh my god, that's V1. I was looking for V2, right? V2 is my actual solution.
Yeah.
So multiply that by 2s plus 1. So how do we check
I
our
see. So,
answer? What'd you say, sorry?
so you isolate, well, pretty much right off the bat, you isolated for the wrong variable.
That's okay. I mean, now I know V1, so I can just sub
Yeah,
that in right here
yeah.
and then multiply it. It's fine.
Yeah.
How should I check my answer? What do you think?
Honestly, it's fine. Like, as long as like we're just exposed to the same sort of like procedure, like I think that will be more helpful because it's like I don't know, it will take a long time to try finding our
Yeah, it will
answers
take a long time.
from wherever. Yeah.
But I don't know for certain that I'm right. I don't know for certain that I
Oh.
did this entirely correctly.
Yeah. So not even just the math stuff at the bottom, like even from before. The circuit, like
Yeah.
yeah.
So possibly it might be worth our time to look at the examples he did in lecture,
Okay.
try it
okay.
ourselves, and see if we get the same answer as him.
Yeah, I like that.
Does that sound good? I will just quickly check if the textbook has a solution. I can't remember 16. I can't remember if it has even or odd. Oh, it has odd. Okay, let's try some of his questions, see if we get it. And then once we can do those correctly, at least we know that we know the procedure.
Mm-hmm.
Otherwise, that's okay. Okay, so lecture notes. I can't remember what week it was. Week 7, I think. 8, I guess. He honestly didn't do that many examples. He didn't spend that long on Laplace. So, okay, so this first day of Laplace was entirely that. Week 8, lecture 2. A long time talking about this. Find the Laplace of that. That's fine.
Oh, and Adam, also, wasn't there filters that was before Laplace?
Yes,
or
we did not. We did not. We didn't do any filter practice. We probably should do that. Not just probably. We should do that. So. Okay, here we go. So here is an example. Okay, this week he just did a bunch of examples. Okay. Well, let's see what I mean by a bunch. He did 16.7. Is this 16.7? No. 16.7. Oh, that wasn't assigned to us. Yeah, that just wasn't assigned to us. That's just fine. 16.2 he did as well. How is that 16.2? I thought the first two questions in chapter 16. 16.2, that's just not 16.2, right? That's weird. He said this is example 16. Said this is example 16.2. This circuit. I don't know. Anyway.
Completely different. Yeah.
Just a different question. 16.7, same thing. Not that. It's weird. So I don't know what he means then by example 16.1, 16.2. No idea what that means. Is he turning this differential equation into a circuit? Is that what he's doing?
No, like no.
No, he's just.
But I mean, so why don't we just go off of what he has in the beginning? And
yeah.
Let's and we just go like that.
Okay, so I'm just trying to see how many examples did he do. He did 1, 2. He did 3 examples in the first lecture, and then week 9, lecture 2. He did. Oh no, I talked a lot about convolution. Yeah. No, he actually only did 3 examples. So let's do the 3 examples. Yeah, I remember he didn't do that many. I remember thinking to myself he didn't do that many. Okay, so the circuit is this 2u of t. Oh, this is the exact thing we were just doing. That's this exact circuit. What am I talking about? 2u of t. So when he says 16.7, he just means 16.30. That's probably he has a different edition of the textbook. That's all it is. Okay. He did this exact
Oh.
question.
So we didn't get that answer then.
Well, let's see his equations that he got. He did KCL. Oh no, never mind. We did KCL together. So he got, for his first equation, v1 minus 2 over s over 1, v1 over s, v1 minus v. So when he says v, he means v2. And then you got v2 minus v1 over 1, v over 2 minus s minus 1 over s. Okay, yeah. He did that. All right. v1 equals... yeah, he just rearranged for...
But, okay.
Okay, so let's... Sub 1 to 2. Oh, just rearrange that one. Okay, there we go. His final expression for v2 was not what I said. But let's see if I can get it, actually. So, substitute. I have to use this here. Oh, yeah, actually, it might be. Let's see. Okay, so I'm going to go from here. v2 equals v1 times that. So, v2, the actual value we're looking for is, so s plus 3 times 2s plus 1 over 2s cubed plus 3s squared plus 7s minus 2 over s. Okay, so then I gotta do something here to make this thing. Do I factor this, I guess? Yeah, I guess I should have left that s out. And then I just gotta multiply top and bottom here by 2s squared plus 3s plus 7. Or 2s.
Why are you doing that?
Common denominator.
Oh, okay.
Makes sense? And now it's s.
Yeah.
So it's, well, it's whatever that is. But that's not what he got. So 4. Well, let's see, I guess. But no, but it's not what he got. Because we have 2s cubed and he got just s cubed. Yeah. Okay, so there's just an issue in how there is a mistake. But not a horrible mistake. Not like we did misunderstood the process. Let's go through his process and let's just make sure we would do the same thing. And then we can move on to the next one. So he got these two equations. We got the correct equations. He then solved for v1 in terms of v2. I solved it the other way around, but no difference. And so that's fine, I think, because that would be s plus 2 over 2. That'd be 2 over s. That isn't the same thing. Unless I solve for the different variable. Did I mess up just like how I solved for v2? Because I had this equation. So he took this equation and solved for v1. Which I think makes more sense. So that
it would make more sense just because like there's less steps to do at the end.
Yeah.
But, like you wouldn't get the wrong answer though.
S over 2 v2 minus 1 over s equals 0. And then this is, this is s over 2 plus 1 v1 what? No. v2 1 plus s over 2 equals v1 plus 1 over s. Oh no, he solved. Yeah. No, he solved for v1. Never mind. That goes on the other side. Okay, and then everything's fine. Yeah. Then everything's fine. Okay, so he got the same.
Wait, so there was no mistake then.
There was no mistake
for that part. Yeah.
Well, for this part, I got v1, and then if I substitute. But is that the same thing as this? I don't think that's the same thing as this. Because if I factor out I don't think that's the same thing as this equation here that I have. I know it's getting very messy, so let me try to separate this out. But this is, if I try to rearrange this, this is going to be V2 plus 2 over S times S over 2S plus 1 equals V1, which is not the same thing as that. Anyway. 2 S plus 1. Because then that would be V2. Yeah, that's just not the same thing. So, yeah, there's some mistake in the thing. Should I just try it again from the beginning?
Yeah, and just isolate for V2 this time.
Yeah.
Or,
Okay.
yeah.
Okay, let me try again. So, how about, like, our circuit was right. So let me just copy the circuit. The circuit's correct. So our circuit's right. Our values are right. So I'll call it what he called it. So he called that V1 and V, just so I'm not confused when I'm reading his solution.
Yeah.
So this is V1 minus 2 over S over 1 plus V1 over S plus V1 minus V over 1 equals 0. So now I'm going to solve for V1. Oh, sorry, I need the other equation. V minus V1 over 1 plus V over 2 over S minus 1 over S equals 0. Okay, so now I'm going to solve for V1. Okay, so then I'll do it here. So it's V minus V1 plus SV over 2 minus 1 over S equals 0. Okay, and now just move that to the other side. So it's going to be V times 1 plus S over 2 minus 1 over S equals V1. I'm going to take that into this other equation, V1 minus 2 over S plus V1 over S plus V1 minus V equals 0. Substitute that in. I'm going to get V1 plus S over 2 minus 1 over S minus 2 over S plus V over S plus V1 plus S over 2 minus 1 over S minus V equals 0. Okay, it's all V's in here now, so I can just start simplifying. So it's going to be V1 plus S over 2 plus 1 plus S over 2 plus 1 over S minus 1 minus 3 over S 1 over S. So minus 4 over S equals 0. V, so it's S over 2, S over 2. It's 2S over 2, so it's just S plus 1 over
There's
S.
still a plus 1 over, yeah.
Okay. Yeah. Equals 4 over S. Common denominator is going to be over S squared. This is S over S. This is V S squared plus 1. S squared plus S plus 1 over S equals 4 over S. So I'm going to get V equals 4 over S times S over...
Wait, sorry, Adam, if you multiply everything by S on the left side, shouldn't you do the same on the right?
Here I multiplied everything by S?
Yeah.
I multiplied everything by S over S. That's just 1.
Okay.
Right? So that's okay. I don't have to do it on both sides. If I just multiply by S, yes. But
Okay.
I multiplied by everything by S over S. So this is that an S on the top? Yeah. So it's just going to be V equals 4 over S cubed plus S squared plus S. And I think that is still not correct. That is still not correct. S squared plus S plus 1. Okay. Yeah, that's not right. So let's take a look at how he did it. He substituted 2 into 1. 2 into 1. So he had V1 minus 2 over S plus this. He substituted this in for V. What? Oh, no, no, no. You rearrange this. Okay. Should just move to the side. Little box. And okay. I'll just follow what he did exactly and see if we're making mistakes. He rearranged everything nicely. So it's just going to be 1. So it's going to be 1 plus 1. That's be 1 over s. Whoops.
Oh,
That's my mistake. Okay.
okay.
That probably was the whole thing. That's v1 over s. Okay. That's v1 over s. Anyway, so he then rearranged. This is v1, so it's 1 plus 1 plus 1 over s minus v minus 2 over s equals 0. So that's just 2 plus 1 over s. So now I'm going to substitute that in. So it's going to be v1 plus s over 2 minus 1 over s times 2 plus 1 over s minus v minus 2 over s equals 0. And now FOIL. So 2v1 plus 2 over s plus v over s 1 plus s over 2 minus 2 over s minus 1 over s squared. Minus v minus 2 over s equals 0. Is that what he got? No. What? What did he do?
Maybe he made a mistake. That's a possibility.
Well, yeah, it is a possibility for sure. But I can't understand what he's doing. What? So I had this. I had that same equation.
Mm-hmm.
Substitute in. Okay, I guess that makes... Yeah, okay. So you just put that in. That's fine.
Mm-hmm.
And now he distributed 2 plus s in. Okay. Okay, that makes sense. He distributed 2 plus 1 over s, 2 plus 1 over s into each thing here. And now, what is happening between this line and this line? He moved... Wow, I have no idea. What's happening between this line and this line? I think those s squareds come later.
Yeah.
So I think he moves all the constants over, so that goes over. And that goes over. And all that's left on this side is that minus... Okay, yes, that makes sense. So he moves...
Yeah, so everything... You see that minus sign?
here.
In between the V? No, up higher. Like
Here?
right above that. Exactly. Everything to the right of that is moved over.
Except this negative v. The negative v is left right
Yeah.
there, which turns into negative 1 times v. Okay, that's fine. And
so why
then-
is that? So he's only picking out the V terms on the left?
Yeah, because
and
he wants to
then-
isolate for v, right? So
Exactly. Okay.
and then he multiplies by s squared, but not right away. He does it for... He leaves it there for 2 lines for whatever reason. I don't know why. What happens between these 2 lines? Absolutely nothing. Oh, never mind. Absolutely nothing, obviously, because this is the
Because it's- yeah.
the division of the... Okay, that's my fault for misunderstanding. And then now we have this. Now we have this. He multiplies both sides by s squared. And
Yeah, exactly. So now so the S, for example, so you see how it's 2 plus 1 over S?
oh, okay, that turns into
inside
that.
it just cancels out one of the S's. So then he's just putting in substituting.
Okay,
Or
well,
sorry.
let's just keep
Yeah.
going like this and see if I get
Okay.
the same thing.
Okay.
Because again, if I make no mistakes, it should be the same thing. 6. So, and writing nicer would help. So let me try to do that. I'll leave all the v terms on this side. 2v 1 plus 2 over s plus v over s 1 plus s over 2 minus 2 over no, that doesn't go over, minus v, okay, equals 2 over s plus 1 over s squared plus 2 over s. Okay, so then v times 2 plus 4 over s, multiply the 2 in there, plus 1 over s plus 1 over 2 minus 1 equals, and now I'll just make all these like that. So 4s plus 1 over s squared. Okay, and then here I can just make all this a common denominator. So this is going to be, well, let me just do everything I can first. So it's going to be 3 halves. 2 plus a half minus 1 is 3 halves. Plus 4 plus 1. So 5 plus 5 over s. What am I talking about? There you go. Plus 4s plus 1 over s squared. So now make that a s and an s, and make that a 2 and make that a 10. So b 3s plus 10 over 2s equals 4s plus 1 over s squared. So v equals 4s plus
Wait,
1.
sorry, Adam. Couldn't you just do that thing where that term that you have, or the term that you have in the brackets for v, you could multiply everything in there by s, so then you could cancel out the s squared in the denominator once you divide out.
Yeah, multiply everything by s. Yeah, yeah.
So you see how you have 3s plus 10 over 2s?
Yeah, so like this. Do that.
Wait, what? How'd your... So what did we have? Yeah, so... No, what I'm saying is you could get rid of that whole s. So you see how you still have s in the denominator once you get
Here.
rid of that?
This one?
No, to the right.
This one?
Yeah, you see how once you do it, then you're only left with s in the denominator.
So if I cancel these two, like that.
Yeah. What
Yeah.
I'm saying is, why don't you just do that, multiply everything by s over s on the left side in the bracket. So you see how it's v bracket?
Mm-hmm.
Multiply everything by s over s. Because then you're going to have 2s squared in the denominator. And that cancels out the s.
Oh,
well.
okay.
It's just like, I don't know, it's just that's my thought process.
Yeah.
but-
I see what you mean.
But whatever, keep on doing what
Okay,
you're doing.
let's
Think
keep
about
going
it.
like this, but yeah,
Yeah.
that should work too, yeah. But anyways, this is 8s plus 2 over 3s squared plus 10s, which is not what he got either. So, what am I
We're
doing
getting
wrong?
bodied right now.
Yeah. What am I doing wrong? What? Am I just not good at this? What's going on?
Oh no, Adam's ego. It's hurting right now.
Yeah. What?
No, but that is weird though. Like I followed you throughout, and like I don't know, I don't see anything wrong.
So the numerator is 4s plus 1 plus 4s. That is actually right. I mean, we multiply by 2 after, so it's off by 2. Right. So the denominator is what's wrong. So the numerator of what's here is wrong. So he does it quite a bit differently from... Did I FOIL this right? That times that is that. 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 That. that equation's right. And this equation was right. And this was right. Oh. S over 2. 2 over S. That's supposed to be S over 2.
Because S's and 2's, they look the same, man. I don't blame you.
Oh my god. S over 2. S over 2. So now, where did 4 over S come from? What?
It seems like you accidentally fixed your mistake.
Well, not where? Here?
Wait.
This would
I
be.
see.
Oh, never mind. I multiplied 2. Never mind. I multiplied 2 over S by 2. And I got 4 over S. That's what it was. But now, anyway,
Okay.
it's supposed to be S over 2 times 2. So it's still 2. And then
So
this
now
is
it's
just
just
S.
S, yeah.
And then this is 1 over S. Those together. Plus 1 over 2 minus 1. Okay. So then here we get 1 plus a half is 3 halves. And then this is S squared over S. So plus S squared plus 1 over S. Multiply by 2 here. Multiply by S here. I get 2S squared plus 3S plus 2 over 2S. Squared, but then that can cancel with that. And so then we get, oh no, that was actually right, 4S plus 1. I still multiply by 2, which isn't good. So let's see. So let's see. Anyways. So then this is going to be 2, no, sorry, over S times 2 over 2S squared plus 3S plus 2. Okay, and this is going to be 4S plus 1. Right, 2 times that over 2S cubed plus 3S squared plus 2S. Let's see how close we are. We are, so you got S squared plus 2. He wrote it all weird. He wrote it as 1 plus 4S over. So S cubed plus 3 over 2S squared. I guess that's what he means. Yeah. Plus S. That's what he got. So, like, close, but not right.
Yeah.
Yeah. S times. Well, in here is some mistake. You want to just try the next one, see if we have better luck?
Yeah, I want to tell you that.
Let's try
I
the
want to
next
tell
one.
you that. Yeah.
Let's try the next one, see if we have better luck. Obviously, we'll try this again next time, but
Yeah.
let's just see. Let's just see how it goes.
I probably need a dip.
Okay.
But I'll watch the recording.
Yeah. Sounds good. Yeah, I'm still recording.
Thank you for the lesson, though.
Yeah. No problem. Thanks for
Have
coming.
a good day.
Yeah. See ya. Bye. Bye, Kevin. See ya. Okay. So let me draw the next circuit. Let's just give this a try. So plus minus. This is 10 e to the negative t u of t. Okay, and then this is our 10 ohms. And we have a capacitor. That's the voltage we're looking for, V of t.
Mm-hmm.
I don't know the capacitance of. Oh no, I do know. Oops, I drew the resistor there. 10 ohms, 0.1 farad, and the current source, which is 2, and then delta of t. Okay, so given V of 0 minus equals 5 volts, what? And then I'm just trying to understand already. I'm trying to understand what he wrote. So, given v of 0 minus equals 5 volts, and then he writes v of 0 minus equals 25 volts here,
Yeah.
which is weird. Why would he just switch it to 25 volts? Unless did he do that? He turned it
Oh, I
into
think I'm trying to remember something. Yeah, that's what he does. So I think I remember him doing that exactly what you're looking at, where it's those two current sources.
Uh-huh.
He does that conversion with the capacitor sort of thing.
Yeah, and that's fine.
Yeah.
That's fine. I
So-
have that in my notes.
But that's not related to the 25 volts, is it?
Mm-hmm. Right? That's what I'm thinking. It doesn't seem like it. I mean, v of 0 minus equals 25 volts. Do they mean the voltage across? The voltage across. Yeah, I have no idea what he means by this.
That's
Somehow,
so weird.
somehow you can connect. That's. And then he just got rid of the current source, so that makes me think that he's drawing the circuit at 0.
Mm-hmm.
But then why does he leave the voltage source there, not as a short circuit? He leaves it as just a regular voltage source. And then this is 10 over, but like he doesn't include the 25 anywhere.
Oh, okay. Adam, so given v of 0 minus, we know it's 5 volts. So I think what he's referring to is the unit step function.
Yeah,
So
it
at
kind of looks
T0
like
minus,
that. Yeah.
so that means at that voltage source right there, at the diagram at the bottom, the second page, there's
Here.
5 volts to the left.
Here.
Diagram. Yeah, there's 5 volts right there at that voltage source. So I think he just tried doing like a basic conversion, and then he realized that the voltage, no, because it should also be 5
But then,
volts across.
but then he should have used 25 here, if that was the 20. So if that voltage was 25, then he would have used 25 here, but he used 5 because that was given.
Okay, honestly, like, yeah, I think we should just ignore that. Maybe.
Yeah.
Maybe it was a typo. Like,
You want to try to find the lecture? Like, you want to look at the lecture quickly?
yeah. Oh yeah. Yeah. Let me
Let's
pull it up.
see. I'll pull it up too. The nine. Oh, I forgot what it was just now. 9 week what? Lecture 9. No, week 9, lecture 1. And let's see how far. I don't know how far. Okay, that's that. That's that question. Okay, he finished that one. Okay, now he's starting this.
Okay.
Now he goes here. Still not there.
Which is interesting. Oh my god.
Okay,
see?
so he doesn't
The 25
actually.
Yeah. Yeah, the 25 is just not related to the question. I think he just wrote that down.
Oh, here. Oh, okay. V of 0 plus. He just.
Okay, so let's do another one. And then I think that's and then I'm going to do a final exam review, and then
No, is he? No,
that's
that's not what I meant to do.
over. So
Is he
Kitty's
gonna
part.
draw the picture?
Okay, great, thank you.
So there was another option you could have. That was me talking.
That it's using
That's weird to hear my own
the math is
voice.
suddenly available. The energy is available to your circuit. Yeah, but I'm saying, but I don't have the impulse here. So the impulse becomes the 20 without impulse. And then I'm going to say V of 0 plus minus is equal to 25 volts. Would you get the same one? Yes, right?
Yep.
So that's fine.
Hold on.
The
here's-
0.5, I understand how the 0.5 ampere came from,
Yeah.
but when current sources, but like when it comes to the extra voltage, I don't understand that the impulse is what
So if I draw a circuit, right? So let me just put an argument there. If I draw a circuit, right? Same, exactly the same.
without the impulse.
Without impulse.
Mhm.
And then we'll say V of 0 plus minus is equal to 25 volts. Would you get the same one?
Oh.
Yes, right?
Yep.
So that's fine. Therefore, these two are equivalent, isn't it?
Okay, so he's saying if he made another circuit where you forget about the impulse and you said that V of 0 minus was 25, these would be equivalent circuits. Okay. Why exactly then he's talking about the fact that the delta function makes like a discontinuity inside the whole system. So I don't really understand that fully. That's a little bit I don't know what's going on there. That's because the delta function is screwing something up, so you can get that the same. But that's not involved. That's not at all involved in solving the question.
Okay, good.
Okay, so at least we can confirm that that's not at all a part of it.
Are you guys on chapter 16?
Yeah,
Yeah.
we're on chapter 16.
Okay. What question?
Well, we're just doing the lecture questions right now because we tried one of the textbook questions, but we can't really check our answers with the textbook questions because Slater doesn't have it. So we're doing lecture ones first.
Okay.
Okay. So okay. Let's try to solve this second. So Laplace everything. So that let me try to do this a little bit nicely. So give it a like that. So the Laplace of e to the negative t u of whatever. So that's going to be, if I remember how to do it. So it's going to be a 1 over s plus 1, and I think it's e. No, is it e? Is it 10? So according to this, it's just 10 over s plus 1. But let me understand how that is. Laplace of e to the negative t u of t minus 1. So the Laplace of the unit step function, I'll go back here. The Laplace of the unit step function is e to the negative as over s. So e to the negative 0s over s. So e to the 0. So just 1 over s. And then Laplace of e to the negative t times something else. That's one of these theorems that I was showing before. This one. There you go. Laplace of e to the at f of t is f of s minus a. So this is going to be 10 over... So if that e to the negative t wasn't there, it'd be 10 over s. But since it's there, I have to do s minus a, which is, so it's s plus 1. It's minus negative, so it's plus. Okay. That makes sense to me. Does that make sense? How I got that?
Yep.
So then that's just going to stay 10 ohms. That's just going to stay 10 ohms. Then this source right here, no, this capacitor, I mean, is going to turn into, well, since I can tell that doing the current one is the best option, we'll do the current one. So the current one will turn into a capacitor, okay, where the capacitance is 1 over s times 0.1. S times 0.
Which is 10 over
so
s.
10 over s, yeah. S. And then in parallel, I need to put an additional current source, which is not the same as this current source. Okay. Which has
And these
value.
have an additive property, right?
I think they do. Yeah, they do. Because note deuce KCl here and here. This current is the sum of the two currents.
Mm-hmm.
Okay, so then the value here is C times V of 0. So 0.1 times 5 is 0.5 amps. And this is a 2 amp, right? Because the Laplace of the delta function is just 1. So check that. Yeah, okay.
Yeah, could you like write that down like a little note?
What am I?
So
what-
like the Laplace of delta t is just 1.
Yeah, that's like the defining feature essentially. That's not the
Yeah.
defining feature, but that's a really important feature. So Laplace
Yeah, I need to remember that. Yeah.
delta of... Okay.
Cool.
So then we have this, fantastic. So yeah, so then these two voltage sources can combine into one. And let's redraw that with that there, just so we're confused by anything. So this is 10 over s plus 1 voltage source. And we have 10 ohm, 10 ohm, 10 ohm. over S. And then this is a single current source, the value of 2.5 amps. Okay, great. I really got it. S is such a rough letter for me because 2's and S's and 5's all look exactly the same. Not exactly the same, but too similar at least for my brain. So it doesn't work out. Should I just invent another S? I don't know. What should I do? So like my 5 looks like that. My S looks like that. My 2 looks like that, I mean. So if I'm writing really quickly, my brain will get these confused. And then S is just that. So should I do like, I don't know. How can I distinguish an S?
Usually, I think
Like
yeah,
that.
exactly. That's
That?
what's his name? I think our professor does that, no?
Yeah, I might actually do that because I gotta do something because that is
Yeah.
not good. Okay, I'll try that, I guess. Okay. Yeah.
What I for 5s, I just make the angle like sharp.
Yeah, like that in the corner there.
Yeah.
Yeah.
Yeah, but when Adam's doing quick maths, you know, he doesn't
Oh yeah.
pay attention.
Sadly. Okay, yeah, this is definitely easier than doing this, but I just know I won't do that. I will just continue to write that. So at least that probably will work. So let me try to do that.
Long time. It took me a long time to get used to that.
Yeah, I'm sure.
There are so many of the questions wrong, and then
That's,
yeah.
I bet. That's probably why we're getting this question wrong.
Yeah, that is true.
Okay, so let's continue. I'm gonna do I'm looking for what voltage? I'm looking for the voltage across the capacitor. So that's the voltage I'm looking for, V.
Yeah, now you could just do nodal.
Now I just do nodal, yeah. So there's a node. It's actually just one equation, one unknown.
Awesome.
So it is let's say V. So V minus 10 over S plus 1. S plus 1.
Over.
Over 10. Thank you. V over 10 plus V over 10 over S. Then I want to subtract 2. Solve for V. Let's see if it works. I really hope so.
So just to clarify, Adam,
yeah.
when you have V minus the other node that's across from something, you're assuming that the current's leaving from that node, right? Like all of these different equations, you're assuming the current is leaving from V.
So it's going like that.
Yeah.
The current's going like that, the current's going like that, the current's going like that,
exactly.
and the current's going like that.
And
so
that's why that's a minus.
That's
exactly.
A
okay.
It is. It's going that way.
Just making sure. All right.
Yeah. Good. Plus V over 10 plus, so this is going to be V times S over 10 minus 2.5 equals 0. Okay, so then now this is going to be V over 5 plus, well, I'll just say V times 1 over 5 plus S over 10 and then
which equals
equals 2 just 5 over 2 plus 1 over S plus 1.
There you go.
Okay, good so far. I'll make this a 2 over 10. So this is V S plus 2 over 10 equals, and then I'll write this as 5 2S plus 1 S plus 1 2 over S plus 1 S plus 2 over 10 equals 5 S plus 7 over. Whoops, that's supposed to be a 2 there. 2s1.
So how does it become plus 7?
5 plus 2. 5 from the s plus 1.
Oh, okay. Yeah. Yeah.
B equals 5s 7 over 2. I'll distribute it. 2s plus 2 times 10 over s plus 2. B equals 50s 70 over. So this is now a product here. So it's going to be 2s squared plus 4s plus 2s plus 4, so plus 6s plus 4. Okay, let's see.
So just
that's
to
pretty-
clarify, you did the FOIL between the denominators, right?
Yes,
With-
yes.
Okay.
And so
What multiplies
Um,
by what? Gives you 4, and plus each other gives you 6.
well, that I could just
Oh.
undo this. I could just undo this here, right?
Yeah.
I could go if I want to factor this. I would just go back up to. I would just go back up to this right here. But I'm comparing now what he did. PCL flow out. Yeah. So he didn't get this.
That's
got-
so weird, man.
He got.
That's so weird.
It seems like we're doing everything right, right?
Yeah.
25s plus 35 s plus 35 over s plus 1 s plus 2. We're not ridiculously far off. So what I got was 5s plus 7. Well, okay, times 10. Times 10 over 2s plus 1. Oh, no, we're good. We're good. Hold on. S plus 2.
Oh, so
So-
you shouldn't have just
So
done the
that's
FOIL.
that's a 5. Well, it's okay. I mean, actually, I need. Oh no, never mind. I don't need to foil. Yeah, there's no need. There's literally no reason for me to foil.
Yeah.
Yeah. Okay. So then this is gonna be 25s plus 35 over s plus 1 s plus 2. There we go. Okay, we've got.
Yeah, we did
we
have
got
the answer.
one.
Yeah.
We got one finally. So now we'll just partial fraction it. So I'll just use this partial fraction. So the partial fraction is 10 over s plus 1 plus 15 over s plus 2. And now we Laplace inverse it. Whatever. It's going to be 10e to the negative
1. Negative t.
t. Yeah, I'll say not really equal, but applies. 10e to the negative t.
Plus 15.
Well,
e
apparently
raised
I have to
power of-
multiply by the unit step function. Why do I have to multiply?
Oh,
by the
yeah.
unit Oh yeah, just because. Why do I have to multiply by the unit step?
I don't think. Okay, because what I'm thinking of is like, if you just factor out the 10, now you just have to do the Laplace of 1 over s plus 1. And
Which
that's
is
just
e to the
raised
negative
power of
t.
minus t. So I don't know how like a unit step could.
So I think that's because there would, if you look back at the original circuit, where's the original circuit? There's the original circuit. If you look back
Yeah.
at the original circuit, there would be nothing until, so it like even though technically at like negative t values you would get
Yeah.
some sort of answer like by the formula that we're about to get here.
Yeah.
There would be nothing until 0 because there's a switch here essentially. So you
I
have to go
see.
back to the circuit and see that. Well, so first of all, let's just like look at the answer that we would get. So we would get plus 15 e to the negative 2t. Right? So that's our v of t. But the thing is, again, is just that until
T is greater than 0, then you'll get that v of t equals that. Is that what you're saying?
Yes, but how does that make sense? Oh, I guess it just means that what they mean is just that you can't use this formula when t is less than 0. So to force that you can't use this formula when t is
You
less
just,
than 0.
yeah, you put a condition.
You just say u of t.
Oh, okay.
Technically, if I didn't put those unit step functions, you would get an answer for v of -5 or something like that. But we can't use that because I don't know, because it just doesn't.
So like, say for whatever reason, okay,
yeah,
our function was, or sorry, our source was 10 e raised to the power of minus t without the u of t. Then our vt would equal our final answer. But because I had that unit
think
step.
So.
Okay.
I think so.
Okay, but either way, that is the right answer, right? That last line that you have.
Yeah. That's the right answer.
Okay. Cool.
Yeah. I want to confirm that. Should I email him and say if the u of t wasn't there?
Yeah. Then. Yeah. Go ahead. Ask him.
Yeah, I will. I won't do it this second, but I'll email him.
Yeah.
You know, he took. I emailed him about one of my quizzes.
Yeah.
And I had to email him because I didn't know my I told you my TA switched between the first and the second
Yeah.
lab.
Exactly.
I had Abbas.
Yeah, I got your TA.
Yeah, I don't know why they did that, but whatever. They
Bro,
did.
but then they switched last lab for me at least. I got Nikhil again.
Oh really?
Yeah, just for that one lab, which was so weird.
For this previous one that you just had?
Yeah, exactly. Yeah.
Oh, that's weird. Yeah, no, I had Nikhil though. Like after I only had Abbas that one time, or twice.
Yeah. Anyway, so you emailed him.
Yeah, I emailed him about the quiz. I got a 50 on one of the quizzes. I was like, well, I want to see what I did, how I got 50. It's just like,
Yeah,
think I
bro,
got
I've
50.
been getting such bad marks on them.
right?
Well,
And-
at least just one of them. Yeah.
Yeah, and so I emailed him. It took him 16 days to get back to me about it. I did a follow-up email even, and no response. So 16 days from the original email
Yeah.
to get back to me on that, which is a significant amount of time to get. I expected he wouldn't respond.
Yeah.
After that
Like,
much
might as
time.
well. At that point, just don't even respond. Like,
Yeah.
come on, you're 2 weeks late.
Yeah, right.
The TAs this semester are just not it.
Yeah, I guess so.
TAs
Yeah.
are usually not it. You get these like rare gems sometimes, but
Very occasionally. Very
Yeah.
occasionally. Like my programming TA, he's pretty good. He explains things. He's helpful.
yeah.
Same, but like I also have this one physics TA, and he's actually a nightmare because like I spent so much like time and effort on all of my labs, and then he
Yeah.
just like it's like he wants to deduct marks. It's not like because there's something wrong with our labs.
Who is he? Which one
Yeah.
is it?
I don't know, Philip or something.
Yes,
Philip
Bourdain
Badera?
or something like that.
Badera? Yeah, I have him too.
Literally, bro. See, that's what bothers me. It's like, okay, so the first lab, okay, he only had like 2 sort of criticisms. Okay, I made sure to get those down for the next one. Then he has another criticism to make. Okay, I'm like, okay, on my second one. So then, like again, like you would expect that every next lab you're refining all those little mistakes that he points out.
Yeah.
But I just got my mark back for my third lab, and there was like 5 mistakes on it.
Yeah,
got worse.
I had a lot on my third one too. Yeah.
So that's what's so weird. It's like I thought, like how can I have more mistakes on my third one? That's just
Right.
adding on and refining compared to the first and second. It's so
Yeah.
weird in that sense. That's so weird.
Literally, like the first lab, it's okay because like you're trying to test things out, right? But
Exactly.
yeah, I don't know what's going on there. I mean, I don't know.
Yeah.
Oh, man.
I don't know either. I don't know. He's okay. He's good at like he
explains stuff
explains
really
things
well.
Yeah, explanations are really good. But yeah, definitely like it's not like easy 90s in all the
Yeah.
labs for this one this time.
Exactly.
Right?
I thought it was just me because like I kind of asked questions during the lab, so I just thought he just doesn't like me because of that.
Yeah. No, I'm sure he probably doesn't.
No, and that's what I kind of like about him is like he's kind of upfront with everything. Like when I came in late today,
Yeah.
I asked him like, oh, like did you take attendance? Because I came in late. Like, could you like not deduct any marks. And he's like, depends if I like you. I'm
Oh,
like,
yeah.
do you like me? And then he's like, yeah. So
Okay. That's nice. That's nice. Yeah.
yeah, he no filter, man. No
Yeah,
filter.
yeah. And that's good. That's he's just being honest. That's how it works, really. He can decide if he deducts marks. But yeah. Anyways, that's good. I mean, that's not good that he deducts marks like that, but that's good that he at least like. I think he's a good TA in terms of explanations and in terms of
Yeah,
getting the labs done. Like, he does help.
He seems more normal when he's explaining stuff. But he
Yeah.
just like every other TA is normal, other than when marking labs.
ELE TAs? Wow. Nonsense. Constant nonsense in ELE. Constant.
ELE?
And they
ELE.
refuse to help you too. So funny.
Literally.
Wait, you're talking about ELE?
ELE, yeah.
Actually, I don't know. Like at first, even my TA seemed a little strict, but like he's been like pretty lenient about everything this
Who is it?
semester. Um, uh, I I I don't know. One second. Let me just.
Is it Nikhil or Abbas? Is it one of those two?
No, it's neither.
Okay,
Oh,
so then I don't.
Then you're chilling.
Then I don't know who it is. Then I. What?
What's wrong with those two?
Well,
Oh,
I had both of them. Abbas he was the first one I had. Just a weird guy. Just like doesn't answer questions at all. Did you notice that,
Yeah.
Ashram? Like
Yeah,
he answers just the wrong. Like someone asks a question, he answers a different question entirely. And just like doesn't answer things properly. Very weird. Not helpful. Not a good time. And then Nikhil is just like, I mean, like he's fine, I guess. Like
Sir cute.
yeah, he exclusively says "Sir cute" in a nice little voice, and it's very funny. But yeah, they all just seem like people who I don't know how they passed ELE courses before.
Yeah.
Right? And they're
Yeah.
just like remembering ELE all of a sudden.
Yeah,
while
they're
doing
just
it.
remembering it as we go.
Yeah, right?
That's so true.
That's exactly what it seems like. So it's weird.
Feeling that my TA, like he remembers everything as he's like going through the actual labs, and that's why he literally does all the tutorial questions beforehand, so he doesn't have to do them in front of us.
Yeah. That's good that he plans it like that. Yeah, that's good.
Like I'd rather prefer like I'd rather prefer like doing it like in front of us, so like it actually helps us, because like that's what happened like last semester. This semester he just like zoomed through all the questions.
Yeah, really. That is difficult for sure. He just zooms through it. Yeah.
All right, Adam. So are we done with the questions tonight, or are we gonna do some more?
Well, it's 9:30 already, so that's probably good for today then.
All right.
That's that. But we'll continue, whenever people have time. We'll continue with stuff. And we'll do filters too. We got to do filters.
Yeah.
I just thought it'd be good to move on
Are
to
you gonna
Laplace.
have a physics study session?
I might on Sunday. I might on Sunday. But we'll see if I am prepared enough by then. Right? I might not be prepared enough, and if I'm not prepared enough, then I can't do it. But maybe. We'll see. We'll see.
All right.
We'll see.
Sounds good. All right. Good
Okay.
session, everyone.
Yes,
Thank you,
for
Adam.
sure. No problem. Thank you for coming. Thank you for coming, both of you.